Let's go over some important examples. And see how we can apply these methods, the truth tables, to analyze more complicated, more compound statements. Example. Check if the following statements have the same values. If you have two statements that, or three statements that they have the same values, you say that, hey, they are logically equivalent. So let us write this down here, logically equivalent, or just equivalent. The first statement is not P and Q. The second statement is not P and not Q. And the third statement is not P or not Q. Okay, so here we have three statements, the first one, the second one, and the third one. Very well. What are we going to do? We're going to form a truth table and check to see if these values are the same or not. If they are the same, we say that, hey, they are logically equivalent. If not, we're going to say they are not equivalent together. So let us start. Since we have two statements, we have 2 to the second power, or 4 combinations. So guys, if you have 3 statements, if in a future examples, if you have 3 statements, if it was 3 statements, you get 2 to the third, or 8 combinations. It means that we have 8 rows. Just be careful. 2 to the third, or 8 combinations. Okay, so let us begin. I have my P, I have my Q. So the very first column is for P. The second column is for Q. Very good. Start from the inner parentheses, P and Q. So write down, let's just make it a little bit wider so I can write easily. P and Q. The outer symbol is negation, not P and Q. What else do we have? So this is for your first statement here, not P and Q. Now let us move on to this compound statement. It has not P, not Q, and also it has not P and not Q. So let's just continue this for the last. Not P and not Q. And finally, for the last one, I'm going to use a different color. Here we have not P or not Q. Not P or not Q. Okay. Very good. So this is our table. Let us start. There we go. PQ, 4 combinations. True, true, true and true is true. The negation of true is false. Okay, very good. P is true, not P is false. Q is true, not Q is false. False and false is false. Well, what about not P or not Q? Not P or not Q. The first one is not true. The second one is not true. False or false is just false. Okay, so we're done with the first row. Let us move on to the second row. Okay, just grab it very wide. Okay, here you go. Your line goes here. Now, what if my P is true? My Q is false. True and false is false. Not false is true. Very good. P is true, not P is false. Q is false, not Q is true. Okay, now we're working with these two. False and true is false. False or, guys, now you have or. False or true is true. There we go. Next row. Now, what if my first statement is false? My second statement is true. True and false is false. The negation of false is true. Okay. Move this a little bit here. P is false, not P is true. Q is true, not Q is false. Now we are working with these two guys. True and false is false. True or false is true. So far, so good. Let me just continue this. And the very last one. Okay. Well. Here we have false, false. False and false is false. Not false is true. Okay, now let us move on to not P. P is false, not P is true. Q is false, not Q is true. True and true is true. True or true is true. Now just check the columns related to the compound statements. So this guy is the truth values for the first compound statement. These are the truth values for the second compound statement. And these are the truth values for the last compound statement. Okay, so this is number 1, 1, 2, 2, 3, 3. Which one of these are the same? The first one and the third one. So since the truth values of 1 and 3 are the same, we say that 1 is equivalent to 3. And we write it this way. We say that, hey, not P and Q is equal to. Sometimes you can use equal to or just 3 lines. Not P or not Q. Well, this is one of the De Morgan's laws. De Morgan's laws. Another formula for you to memorize. So we say that if we distribute the negation over and becomes or, the distribution of negation over and is or. So if you distribute negation over and, you're going to end up with or. So if I distribute negation over or, it's going to be and. So it's a nice conclusion here for us that the negation of P or Q is equivalent to negation of P and negation of Q. This is the second De Morgan's laws.